Welcome back, everyone. We're going to do yet another universe sandbox. This time we're going to be discussing um, how to terraform the moon and the challenges that entails. So this was a viewer request. So if you're watching, hope you enjoy this. Um, so first things first, we got to bring up the Earth and the moon. There's a lot of challenges when it comes to terraforming the moon. Can it be done? Absolutely. Maybe not today or tomorrow, but you can't terraform a world quickly anyway. So it's going to take place over thousands of years. You know, it's going to be a very slow process, but I'm certain it will happen. As I said in another video, Mercury is going to replace the moon as the industrial hub of the solar system, and the moon will be left to pretty much just be a tourist location. You know, place for Earthlings to vacation, but yet not be too far from home because, you know, like I said in that video, it's the only place in the solar system where you can still communicate instantly. It's the only place in the universe where you can still communicate instantly with people off Earth. So, excuse me, my voice hopefully sounds a little better this time. What I'm doing right here is I'm trying to align the Earth so that the sunlight's coming in from the left of the screen. And what I'm going to show you is how the moon, come on, get behind the Earth. I believe it's pronounced magnetotail. The sun, of course, hits the left side of the Earth here with the solar wind, and that strips, you know, hydrogen and helium from the upper atmosphere. What most people don't know is that the Earth actually creates a shadow for the moon. This is true. You can Google it. You don't have to take my word for it. But the sunlight, the solar wind comes in, hits the Earth. Okay, the Earth's got a magnetic field that creates this bubble that pushes the solar wind away from it, and that tail protects the moon for 3 to 5 days out of every single month. Now, 3 days of total protection with about 2 more days of like partial protection as it moves in and out of the Earth's magnetotail. So, why am I bringing this up? Because this displays how you can protect not only Mars, but the moon from the solar wind, how we can give it an atmosphere and still protect it. One of my favorite YouTubers, Isaac Arthur, has illustrated in many of his videos, and he's far, far more intelligent than I am. But, you know, as he's pointed out several times in his videos, it doesn't actually require a lot of energy to create a planet-sized magnetic field that is, it's easy to understand. You see the Earth, and you say, oh my God, it's taking the whole Earth to make this enormous magnetic field. But truth be told, the Earth is actually really terrible at creating a magnetic field. We could imitate the Earth with something like a medium to large nuclear reactor. So the idea is to, real quick, reason I'm recreating Halley's Comet right here is because one of the, well, I guess you should say the dominant theory on how to terraform the moon is to hit it with 1,000 comets the size of Halley's Comet. The reason why they selected 1,000 in the thought experiment is because 1,000 would increase the spin of the moon somewhat. If you angled them just right, you could increase the spin, the rotation of the moon, because it's currently at trying to do too many things at once. What I'm doing is I'm currently making Halley's Comet 1,000 times more massive. Rather than hit the moon with 1,000 individual comets, we're just going to increase the size of Halley's Comet by about 1,000 to mimic the amount of water that 1,000 comets, you know, would leave on Halley's Comet. And I screwed up because I did not impart Halley's Comet with any kind of momentum, so the moon is just pulling away from it. I'm going to have to edit this and put Halley's Comet back in front of the moon. So just bear with me a second, because the moon's traveling around Earth much faster than Halley's comet is falling towards the moon. So let me just put this in front. But yeah, so the idea is you take a medium to large nuclear reactor's worth of power, right? You place somewhere in orbit or a Lagrange point, you place this artificial magnetic field in front of a body, and therefore you shield the entire world, because of course the solar wind's not going to be hitting the night side of the planet. It's pretty much just coming in directly. Let me see who that is real quick. Okay, not important. Yeah, the solar wind's coming directly from the sun side, so you place this magnetic field between a world and the sun, and you create an artificial magnetotail to protect either the moon or Mars. In this case, we're talking about the moon. So with that in place, though, the moon's gravity is sufficient to hold on to an atmosphere for a very long time. It can hold on to oxygen and carbon dioxide indefinitely, and hydrogen would very slowly sputter away, very slowly. It would have to be random collisions that it would accelerate individual hydrogen atoms to the point that they escape lunar gravity. But that left a nice little crater too. So what we're going to do, I think the moon, it's hard to tell because it's so gray, I think the moon is covered in ice though. It looks like it's icy because the moon's surface is averaged out at 263 degrees. Of course, in the sun side, it's much hotter. It's about 200 above instead of 200 below. So I'm probably gonna have to artificially change this temperature here. But one of the great difficulties, we can add water to the moon. I'm gonna change the temperature, make it more comfortable, more Earth-like. And to do that, I'm going to have to give it an atmosphere. So we're going to stick with the 40% Earth's atmosphere, pressure-wise. Oh, excuse me. Hiccup. There we go. See the color change? All right, so now there's an atmosphere. It's kind of hard to tell because the atmosphere is actually colored gray. So I may have to end up going with another version of Universe SANDBOX because I don't believe this particular release has the I don't think it does. It doesn't have the colors available for you to change the atmosphere, make it like a bluish tint. Okay, come on. Well, what's the holdup here? Let's see, 65 Fahrenheit. That's just about 12 Celsius, I believe. Right, still, it's showing no water, so looks like that water immediately evaporated off into space as soon as I made the temperature around room temperature. As I said in the previous video, and honestly, modern Universe SANDBOX may have fixed this problem. I tried to toy around with it, and I didn't get too far into it before I got frustrated and quit. But older Universe SANDBOX, at least, a world the size of the moon does not hold on to water or atmosphere. It just like instantly vanishes. And that's not the case in reality. Of course, we're talking tens of thousands of years. The reason I'm increasing the mass is so that we get an accurate topography, with the highs and lows of elevation of the moon. And I'm locking the radius so that when we add water to the moon, we get an accurate representation of how deep any seas or lakes will be. So, but yeah, about the daytime, I wanted to point this out really quick. Unless we change the moon's rotation, a day on the moon is going to be 14 days, and a night is going to be 14 days. So that's going to be very difficult for life to adapt to. Some life will be possible, A friend of mine pointed out that, Alaska has a lot of trees and whatnot, but the problem with Alaska is the town formerly known as Barrow. I can't pronounce its current name. I'll put it up on the screen. But the town formerly known as Barrow is the northernmost town in the United States. And if you look at these pictures, you'll notice something. You'll notice that there's something missing. And that something missing is trees. Nothing can actually grow in Barrow taller than about a foot. It's got some moss, some scrub grass. Bear with me. I gotta change this to 1,000 times more massive so that we get an accurate representation of the water. But yeah, the theory for the predominant theory for man, I forgot about the time. I should have slowed that way down. Okay, so that's slammed into the moon. The predominant theory for terraforming the moon is to use about 1,000 Halley's comets worth of water and volatiles, and to strike the moon in such a manner that it speeds up the rotation. But you could always just introduce that same amount of water to the moon. Remember, water vapor itself is a very, very potent greenhouse gas. It's actually the dominant greenhouse gas in Earth's atmosphere because there's so much of it. But you can't really do anything about that. We can't change the clouds. We can't change the ocean. So that's why we focus on carbon dioxide. That's a much, much, much smaller percentage of the atmosphere. And it's something that we can do something about, should we choose to. Of course, the debate is whether we should, how much we should. It's a cool little effect there. I love the meteor, the impact site, cooling. And there's Mr. Earth or Mrs. Earth in the background. But yeah, okay, so let me check okay, so we got water, but I'm not seeing anything on the surface. Oh, getting back to Barrow, or the town formerly known as Barrow. The reason why nothing really grows, I should say no trees or anything grow there, is because, there we go, we're getting some water now. I'm going to check Earth in a second, see how comparable the water levels were. We might have lost a lot of water vapor, or a lot of water, period, in that impact. I don't know how hard that hit the moon. Looks like it hit the moon pretty hard. So you're going to have a lot of material bouncing off into space and just being lost to space because the moon's gravity is so weak. But yeah, look, check this out. This is cute. You got some tiny little lakes in the northern hemisphere, I should say. It's a good sized lake there. But yeah, I like that I like the physics in this. The water finds the lowest locations and pools up there. We're gonna see the atmosphere is, we lost some atmosphere to space. Remember, I made it 40% Earth's. Now it's like less than 20%. So, the pressure's too high. Hang on. That's almost 28 atmospheres. That's crazy high. Yeah, it's a lot of things to juggle. I'm obviously somebody who can't walk and chew gum. That should be 40%, not 30%. Hang on. There we go. But yeah, the town formerly known as Barrow, northernmost U.S. town and the very tip of Alaska. It's in the Arctic Circle. The reason why you don't see any trees is because you get such long periods of darkness. But it's not as dark as it would be on the moon. On the moon, you're talking about, near the equator, you're talking about 14 days of pitch black darkness. Whereas, on Barrow, most of the dark nights are kind of like twilight. It's like when you get up early in the morning and the sun hasn't quite come up, it hasn't crested the horizon yet. It's pretty bright outside. That's how Barrow looks most of the time during its night, quote unquote night. So, But yeah, so that's not going to be possible on the moon. So we might see artificial means of lighting the moon. It would be much, 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 much easier, 1,000, 1,000,000 times easier to create a artificial shade for people on the moon during the day that orbits and gives the people on the surface a 24-hour night and a 24-hour day. I'm trying to bring the moon's water level up to what Earth has, percentage-wise. It looks like we've got a fairly large, pretty much a single continent, single landmass, I should say. It's not a continent, and really nothing on the far side. That's crazy. But this does illustrate a fact about the moon and the Earth. The far side of the moon, the side of the moon that faces away from Earth, is many, I think it's 40 kilometers. It's 40, I have to look it up, Google it. It's like 40 or 60 kilometers lower than the side facing the Earth. So the moon's a little lopsided. The side that faces us has a much higher elevation than the far side. So, and this water illustrates that. There would basically be a giant Pacific Ocean on the moon's far side were we to terraform it. Now, the really cool thing is you would still have a lot of life possible at the north and south poles, even without an artificial sun, a shade and a mirror to create, an artificial day and night. But that would be far easier than spinning up a planet's rotation. And that's something that people on the moon could do, 1,000 years from now. But listen, I hope you've enjoyed this video. Give me some ideas on what you want to see next. I'm going to probably find a different version of Universe Sandbox because I don't like the fact that this doesn't have clouds. That really irks me. I want to have clouds. So I'll catch y'all later.